So how would you find the volume of a triangular-based prism? So let me share my whiteboard here. And let's get this out of the way. This is the squeeze theorem from calculus. Fun. But look, let's say I have a shape that looks like this here. So I have a triangle there, and I have a congruent triangle elsewhere. And we can connect here like that there. We can connect this here, and we can connect that there. So this is a triangular-based prism where the area, this is the base there, right? This is the base here, and here in the back, you have a congruent base. Now, how in the heck do I find the volume of something like this? The volume of a prism is capital B, lowercase h, where you have to know what these things are. So this is what these things stand for. Capital B represents the area of the base, where in this case, the base is this triangle. That's this triangle. These guys are the bases. The congruent faces, these guys are the bases. And then lowercase h, the separation between the congruent bases. So let me use a color here. That is your lowercase h, because it is how far away this triangle is from this one. Like on a table, if I took the shape instead on my table, this shaded triangle would be what's on the table. And this is the one that would be up in the air. And so h is the height of the whole solid. So how do you find the area of a triangle? 1/2 base. And I'm going to use A for altitude. You see this here in yellow. That's A. And this here, that's B. Right? So A is the altitude. And then B is the base of this triangle. So the volume would be, well, capital B is the area of the triangular base, which is 1/2 times B times A. And then H we said was just H, right? The height of the solid. So this is the general formula for the volume of a triangular prism, where B is the length of this triangular base. A is the altitude or the height of the triangle. And lowercase h is the separation between those congruent triangular bases, the height of the solid, if you will. Now, that's where, this formula pertains to all triangular prisms. But I know that we're dealing with related rates. And for now, if you look at that one word problem, I think it was number 20 on your homework, where I think for number 20, they said specifically that this h was 12. And I want you to see that that h can be turned into 12 permanently. You can replace h by 12 because for this problem, this h is not going to change. Because look, right now, let's say this is your water level. Let's say that's your water level, okay? Notice that the water level right now, the h is still 12. Let's say a few minutes from now, let's say the water is up here in green. So now the water is taller, but guess what, folks? It's still going to be 12 for the height. So for that reason, I want you guys to see that this lowercase h would not change. You know what is going to change? What is going to change is this here in let's go pink. That is going to change, right? You know what else is going to change? This is going to change. So little a and little b, these guys are changing. But this h is always going to be a fixed 12. So for that reason, what we can do is we can update our volume formula. I think in that number 20, the goal was to find dA dt. A represents the height of the water. So I want to find dA dt. So you know what I'm going to do? I'm going to keep A. I'm going to keep A, and I'm probably going to try to get rid of this. I want this to be gone. How can I get rid of B? They said something like, was it like, I think it was 3 and 3, right? If you're looking at the word problem, I think they said that this here, that's 3, and that this is 3. So I think they're trying to tell us that whatever, here in blue, whatever this is, that this is the same. I think they're trying to tell us that this here is the same as that there. I think they're trying to tell us that, A is the same as B. I think that's what they're trying to tell us. That's a proportion. They're always the same. That the height of the water is the same as the length of the base of the triangle, of the water. And so because A and B are the same, I can turn one of them into the other. So I want to keep A because my goal involves dA dt. So I'm going to get rid of B. And because A and B are equal, what I'm saying is I'm going to turn that B into just another A. And so now I can update my equation even more. And now you guys can go and you can find dv dt, that'd be 12a, dA dt, and I'll let you continue from there. The hard part was just the setup, my gosh, because it's a triangular based prism and you have a lot of components to keep track of. So hopefully that helped. Again, just finish this problem on your own and please let me know if you have any questions and I'll gladly respond.